Cryosphere and Mountain Hydrology Group, led by Francesca Policiotti, joined ISTA in 2023. Austria has a strong history of glacier monitoring, yet many processes remain uncertain. With accessible sites nearby, we can investigate them more closely. In 2025, we visited the Pasterzegletscher to explore setting up a new monitoring site on this emblematic glacier.
We are working at the Institute of Science and Technology, Austria, and we are here to study Pasterzegletscher, which is the biggest glacier in the Eastern Alps.
As you can see, we have quite a lot of diverse equipment to pack, from scientific equipment for a weather station, from a drill to drill ice stake, elevation stakes, a drone for some aerial imagery, videos. We have equipment for digging in the debris to look how thick it is. We have various wind sensors, we have our own personal equipment, we have foods, we have a series of other structures for the station. And it's a good job. There were 6 people, which was quite a lot to carry.
So here we are, starting the way down to the glacier. We are carrying quite some equipment. So yeah, it's not the easiest hike. So this was the glacier in 1980. You can see. And now, the glacier now. Almost no glacier, basically. Or much less.
So here we are by the position of the glacier in 1995. And this around this era is a very important part for this glacier because there were major studies here on the Pasterze during the year of 1994 and 95, which was looking at how the glacier interacts with the atmosphere above it. And this is something we're also interested in restudying now in the current period. So this is really interesting to think about how the glacier was then, how it is now, and what that means about how the glacier responds to climate change now and in the future. For our first full day on the glacier, weather's nice, day's calm, the glacier's looking beautiful, ready to go.
Yesterday, we left some of the equipment next to a stream to cross. We're gonna cross that stream, then walk a bit more up all the way to the glacier. Then we'll put crampons on, get on the glacier, do our work. Then we'll go back on the other side. There is a rope to cross the big stream. And then we'll be back. It's gonna be fun. So we are now on the debris-free part of the glacier. We crossed all that area over there.
So here we are at an automatic weather station installed here on the Pasterzegletscher. So this was installed approximately in 2008 by Geosphere. So this was formerly the ZAMG here in Austria. And this is a weather station basically recording a whole bunch of different information regarding the state of the lower levels of the atmosphere just above the glacier. So we have various instrumentation here, ranging from the top left here we have a radiometer. So this is recording information about the radiation coming in from the sun and being reflected by the bright surface of the glacier, and also the information about the radiation from the clouds. We have then on the top of the mast we also have a wind sensor, so seeing how fast the wind speed is going and giving an idea about where the wind is coming from, whether it's this cold wind blowing down the glacier. We also have measurements up the top here regarding air temperature and humidity of the air above the glacier, and also a sensor here on the far top right, which is a sonic ranger. So this is basically the idea in winter. This really important snow layer which can accumulate. This instrument is basically sending a sonic pulse between the surface and the instrument. And the shorter that distance implies that we have more snow. So this sonic pulse needs to travel a shorter distance. So this gives us an important sense of, during the winter when we're not really coming up here to the glacier, how much snow is accumulating, and which tells us something about how healthy this glacier might or might not be during the summer. So here by the lower portion of the glacier, over the debris, we have the team installing a small weather station, which is going to look at the change of the weather and the fluxes of the temperature, the humidity and the wind speed over these lower levels of the atmosphere just above this area of rock debris here. So here we've installed one of our small profile towers. So again, we have measurements of wind speed and direction, temperature and humidity on 4 different levels. So the idea of this is also to look at how the profile of the wind and the temperature is changing with the height above the surface. This rock surface, this debris can heat up in the sun. So this can also produce warmer temperatures here at the lower parts of the profile. But also the wind is also being affected by all of this rough terrain here that we see over the debris and the ice behind us. So the idea is then we can use this tower information to tell us something about how rough this surface is, which is really important when we talk about how the air exchanges energy to the glacier surface. That energy is critical to determine how much the glacier might melt.
We want to measure the glacier debris concentration, and to do that, basically what we do is we clean an area, let's say 2 by 2 meters, and when we come back, we measure how much there is in this area that we cleaned a month ago.
Now the team begins installing ablation stakes, which are used for measuring surface melt. Drilling into the ice requires a specialised Kovacs ice drill. The process is physically demanding, so the team takes turns to drill through the ice.
Now we've drilled our stake, the teamwork. Now we're going to take it out, and then we insert our ablation stake. This is a thin PVC tube with various markings along here. As the glacier is melting, it will be melting relative to these marked points of tape here. So we have a reference of how much the ice is melting through time. So I'm just going to install this here to the hole.
The team installed 2 weather stations on the glacier to record detailed surface and atmospheric conditions, and made some manual debris thickness measurements. Now, as the field campaign comes to an end, it's time to head back to Vienna. The instruments will continue to collect data for about 6 weeks, capturing how the glacier evolves. Once we return, we'll retrieve the stations and download the data to do further analyses.
So here we are again. Not much equipment this time because everything is on the glacier. So going down to the glacier, we left instruments there measuring for more than a month, and now we are hiking down. We expected some rain, but we are having clear skies. Wonderful day. So team 2 is arriving to station number 2.
Ciao.
and we have a bit of a dramatic ending of our tower number 2 because it totally fell. As you can see, it's completely on the ground, not standing. So we will see what happened. So we are now on the quest for debris thickness measurements. So we're just walking around following a pattern on the map, some points that we want to sample, and then we go there and we measure the debris thickness on those points.
The debris layer on a glacier has a critical control on its fate. The key variable is its thickness. A thin layer, just a few centimeters deep, reduces the ice's albedo, causing it to absorb more solar radiation and accelerating melt. However, once the debris exceeds a critical threshold, its insulating effect dominates. It reduces the conductive and turbulent heat fluxes reaching the ice, substantially reducing melt compared to clean ice. Understanding this dynamic is essential for accurately modelling glacial retreat and predicting future water resources for millions.
Started raining, it's not great, but we finished doing debris thickness measurements. So we have our weather station fully packed in our backpacks, so our backpacks are a little bit heavier now, and we're just gonna head back under the rain. Woohoo! Let's go! We successfully retrieved all the instruments. We met with the 2 teams, but it's still raining, so the way up will be a little bit tough with all the weight, as you can see. We made it!
Yay!
With all the heavy backpacks. Woohoo! All alive, no injuries, just all completely wet and tired. That's all from the Großglockner and Pasterzegletscher. We have now made it to destination with all the equipment. We will now go to the accommodation, have some dinner. Tomorrow we'll go back to Vienna, download the data, look at the data, and see what comes out.
Monitoring mountain glaciers is essential to understanding how these fragile systems are changing. Fieldwork in the mountains is never easy. Instruments can fail, weather can shift in minutes, and plans often need to adapt. Yet every measurement and every observation bring us closer to understanding these remarkable and complex systems.